Here is the first real lesson of calculus. So this is going to be 10-1. We're going to go over the definition of a limit. Now, when it comes to limits, this kind of concept opened the gateway to calculus. And its discovery basically allowed us mathematicians, you mathematicians, to bypass typical concepts that would be considered illegal, like dividing by zero. Now, if you remember, when you do divide by zero, you do get that undefined value. And so we kind of classified that as an illegal thing. But now that we're introducing this concept of limits, we're going to be able to push through that and kind of see what it means. Now, limits allow us mathematicians to see where the problem is going, even though you may actually never get there. Now, I use that phrase, get there. It's like, wait, what? You're going to see what that means here in a second. So this following activity is going to give us some insight on what that limit is. So now let's examine this function x squared minus 2x minus 8 divided by x plus 2. Now, if I were to ask you what the domain would be, you would have to sit there and think, okay, well, what would be my restrictions? I don't have a radical. There's no log, but there's potential for me to divide by 0 here, and so I would have to say in the denominator x plus 2 cannot equal 0, so x cannot equal negative 2. So my domain would be, bam, I can't have a negative 2. Now if we look at it graphically, this function here just represents a line. But we said that the domain, it can't be negative 2. So that means that somewhere here at negative 2, there's going to be an issue. So let's dive deep into this a little bit further. Now what we're going to do is, because we know that the domain restriction, or x can't be negative 2 in this instance, we're actually going to use limits to help us find what the value would be. Now remember, when I said this idea of limits, going back to this, I said that you may actually never get there, because if I do get there, well, that value is undefined. So this means we're going to have to make some sort of assumption about what's going on. And so we're going to use a tactic. What we're going to be doing is we're going to approach that value of negative 2, right? We said that x can't be negative 2. And so what we're going to do is we're going to approach it from both the negative side, which we would say from the left, and we're going to approach it from the right side, which we would say is the positive. So we're going to approach it from those two directions. So this is going to actually be a little activity for you. What I want you to do is go ahead and use your calculator, and I want you to start plugging in values. So pause the video, use the calculator, plug in those values, negative 10 into the function, negative 4 into the function, negative 3 into the function, negative 2.5, etc. And then you're going to do the same thing approaching it from the right. So I'm going to give you guys a moment. Go ahead and pause it. I want you guys to go ahead and fill that in. Now that that's been filled in, if you notice, there's something that we can conclude about both of them. It seemed that as I approached it from the left here, what ended up happening is that it looked like it was approaching this value of negative 6. And the same thing happened when I approached it from the right. It seemed like it approached this value of negative 6. As I was getting closer and closer and closer to that negative 2, it was becoming more clear and more apparent that the value that it was approaching is going to be negative 6. Let's go back to when I originally graphed this. When I originally graphed this, if you looked at, remember I said that, wow, this negative 2 has to be undefined, but it looks like it's approaching this value of negative 6. So what we do to conclude that it is negative 6, we're going to go ahead and write it as a limit. So we're going to say the left-hand limit, and this is notation that we need to practice and we need to know and be able to use. We'll say the left-hand limit, the limit as x approaches that negative 2, right? We said I wanted to approach this negative 2 here because that was the undefined value in this instance. I said let's approach that negative 2. Now from the left, which means from the negative side because the negative side is the left side, of x squared minus 2x minus 8 over x plus 2 is, well, what did we conclude? We concluded that it was negative 6. Now we're going to approach from the right. So go ahead and pause it, kind of think about it. How do you think I would write this limit? And it's going to be very similar. But for the right-handed limit, essentially the same thing. The limit as x goes to negative 2, but this time, because we're approaching from the positive, we're going to write it with this plus symbol. And that means that we're approaching from the positive side of that same function. Well, we can conclude the same thing. It's going to be negative 6. Now, when the left hand and the right hand limits, as it approaches that same value, so notice it approaches the same value, the left hand limit, the right hand limit, they both are approaching the same value, which is negative 2, and they equal the same value, so negative 6, we would write it like this. Notice there's no plus or minus there. The implication of this is that we've already maybe even essentially tested both the left and the right. Now we're going to figure out how to calculate the limit analytically in these coming lessons, so we may not necessarily have to break it into this left hand, into this right hand. We might be faced with scenarios that we can only break it into a left-handed and right-handed limit to be able to conclude what that is. The idea here, or the premise, is that we are approaching this value of negative 2. We've shown that it comes from the left, it comes from the right. They both equal the same number, so what we can do is we can say that the general limit as x equals negative 2 is going to exist, and it would be written like this. So the limit as x approaches negative 2 of my function equals negative 6. And that could be written with any function. So the limit as x goes to a of any function, if we know that the left-handed works, the right-handed works, they equal the same value, then we would say that it's going to exist. So it's important to remember this. Write this down, box it, bubble it, whatever the case may be. But for the general limit to exist, both the left and right hand limits, as they approach a value, have to also exist and be equal. They have to also exist and be equal. That's important to remember. Now, let's look at instances where our limits do not exist. So if you notice, if I plug this into my graphing calculator, this was the function that I plugged in. It was this piecewise here. And I said, hey, the limit as x approaches 2 of this function. And so we're approaching this 2. If you notice, the left-handed limit is approaching the value of 1. The right-handed limit is approaching the value of 5. Well, the left-handed limit does not equal the right-handed limit, so therefore the limit does not exist. So if I were to say, I would say does not exist. This is the sine of 2x or 2 pi over x as it approaches 0. This looks like a mess, right? But it looks like simultaneously my graph is at positive 1 and negative 1. And so as I approach this value, depending on which side that I approach it at, it's going to be one negative 1 and one's going to be positive 1. How does that work? So therefore, that's why it does not exist. And you could even look at this and conclude that it is not approaching a single value. It's not like it's moving down to a value, or you can conclude like if my graph did this on that side and that side, right? It's moving at least towards a single value. In this instance, it's not. It's kind of chaotic, right? It gets more chaotic as it approaches the middle here. So they would say that the limit does not exist. Now this is going to be weird, but we also need to understand this when we look at asymptotes. Now notice, as x approaches 0 from the left hand, it's going to go to negative infinity, right? It's going down forever. As it approaches from the the right, it's going up, so it's going to go to positive infinity. Now, yes, the limit is approaching infinity, but infinity is not a defined value. So even though we can conclude maybe that the limit is approaching a certain value, such as infinity, because it's not a definitive value, we would still conclude that the limit does not exist. But in this instance here, it goes to negative infinity, goes to positive infinity, because as x goes to 0 from the negative does not equal x goes to 0 from the positive, does not exist. On this one here, as x approaches 0 of 1 over x to the fourth, now same thing. We're approaching from the left hand, it's going to go up to infinity. Approaching from the right hand, it's going to go up to infinity. Now, yes, the limit as x goes to 0 from the negative, we can conclude that's infinity. The limit as x goes to 0 from the positive, well, that goes to infinity. Well, those do equal each other. So we can say that this does equal infinity. But if I asked you, does the limit exist, we would still say does not exist. Even though the limit does equal infinity, the limit still does not exist because it is not an actual value, right? We don't know the defined value of infinity. It's not a defined value for us to say what it is. So let's conclude the lesson. First thing, we said, what are limits? Now, just to kind of give a non-ultra definitional explanation of it, a limit is how we are approaching the value, right? And it's as I'm approaching a certain value. So we said the limit as x goes to a of my function, and the idea here is as x approaches this a, as we get closer and closer and closer and closer and closer and closer to infinity closer, right? As small or as close as I can possibly get to that value, what can I conclude? And that's essentially what a limit is. As we approach that value, what is it that I conclude? I may never get there, right? Because if I do get there, it's undefined. But what can I conclude based to as close to that value as I can possibly get? Then what is a left-hand versus a right-handed limit? Remember that a left-handed limit as x goes to some value from the negative, and the right-handed limit would be as x approaches some value from the positive. Now remember, for the left-handed limit, what we're doing is we're approaching from the negative values, and we're getting to that value from the negative. The right-handed limit is we're approaching from the positive values, and we're getting closer and closer to that. What are instances where limits do not exist? Well, for the limit to exist, they have to be defined. So the limit as x approaches a from the negative has to exist, and the limit as x approaches a from the positive has to exist. But then also, these values have to equal each other. This is for it to exist. Now, if this is the case, where they do not equal each other, then my limit will not exist. Or, remember we said defined, so even though these can be approaching the same value of infinity, because infinity itself is not a defined value, I would still say that my limit does not exist. This does conclude our lesson. If you have any other questions, please leave them in the comments.